Okay, so just to add to my previous answer here, I said that this line is not a part of the domain. So I guess technically, the standard is that you draw this line with a dotted line, and then you shade everything to the right or to the top of this. And this red shading means that everything to the right or the top of this line, and the dotted line means that the points on the line are not included in the domain. And that's sort of a standard way of indicating what the domain is. All right, now for this one here, you want y minus x squared to be non-negative, right? Now, is 0 okay? Yeah, the square root of 0 is actually 0. It is well defined, so that is okay. And so the domain is a set of all points where y is greater than or equal to x squared. So that would be all of these lines on the parabola and all the points sort of inside of the parabola, if you can define what the word inside means. Okay. Now, technically, if you want, if you write this, I'll give you full credit. But if you want to write the mathematically accurate way of what the domain is, you'll say that the domain is a set of ordered pairs, all ordered pairs x, y, such that this vertical line means such that y is greater than or equal to x squared. So this will be the perfect way or the most accurate way of writing the domain. Remember, the domain is always a subset of either R2 or R3 in this context. Okay, so what's the range? Well, so the range is, because this is a square root or a positive square root of some number, namely y minus x squared, the answer is going to be all of the positive numbers. Like, now, does it go to infinity? How do you know that this goes to infinity? Well, x could be 0, right? So if you restrict this function to all the points where x is equal to 0, then this function will simply be the square root of y, which does go to infinity as y goes to infinity, right? So the point is, that this number, f of xy, can be made arbitrarily large. It just doesn't go below 0. So the range is going to be, in this case, 0 to infinity. Okay, and of course you can not include the point infinity because there is no such point called infinity. And so that's the answer. Okay, now it may have an upper bound. In this case, it just does not, right? Now, here's the idea of a boundary. Now, if I ask you what the boundary is for this domain, you would probably say the boundary is this parabola, right? Because one side is included in the domain, the other side is not. So here's a definition of a boundary. Watch carefully here. The boundary is the boundary for any subset. Okay, so boundary of so the boundary is for any subset S is the set of all points, okay, such that every open set including that point has a points in S and points outside of S. Points in S and points not in S. Okay, so that's what it means. Now, let's dissect this a little bit because this must be maybe a new concept here. See, let's say this is, this set to the right is my subset S. Okay, and I am claiming that this point right here is a set. It's a boundary point. Now, why do we call this a boundary point? Because every open set including that point, okay, so you take any small boundary, any small open set including this, and by the way, this is called the neighborhood of this point, okay, and it makes sense, right, because it looks like, all the points close to it. Sometimes it's called epsilon ball if you think of this as the radius epsilon. all the points within the epsilon distance of a point, let's call this point x, right? So we say x is a boundary point because any small open subset of this space, or any small open set, including x, does contain both the points in x and points outside of x, right? And so x is a boundary point, because every epsilon ball about x, or every neighborhood about x, i.e. every open set that includes x in its interior, is going to have a point in S and point outside of S. Okay, so X is a boundary point, and in this case, of course, all of these points are boundary points, and so the boundary for S will be this entire line, because every single point has that property. Okay, so in this case, this was the boundary. The boundary for this domain was y is equal to x squared. Okay, and that is the boundary, and boundary is usually a line or a curve or something like that, not necessarily. Okay, so if on your homework, if you're asked what the boundary of a domain is, think of this definition, okay, and you will see what to look for. All right, let me give you another example of a multivariable function. This will be, let's say, f of xy is equal to sine of the square root of x squared plus y squared, right? Find the domain and the range. And see if this makes sense. All right, so the question is there any reason to kick anybody out of the entire plane? So every point on the plane shows up, and parentheses the ordered pair xy. Is there any reason to kick out any of the ordered pairs xy from the domain of this? And it turns out, well, this is always defined, and in fact, it's always positive, or at least non-negative, right? So there's no way to make x squared plus y squared, maybe I should say, x squared plus y squared is always non-negative, okay? The least it can be is 0 for all x and y, okay? And therefore, the domain is, no, I don't see any reason to kick out any ordered pairs, so the domain is the entire R squared. Now, again, do not say the set of all reals, okay? Because now you're in a different dimension, okay? So the domain has to be a subset of R2, in this case, the entire R2, because there's no ordered pair XY that needs to be excluded to avoid any kind of an undefined expression. All right, so what's the range of this? Well, because of the sine function, the range is going to be from -1 to +1. That's it, right? And the z value, or f of xy, that value will not be more than 1 and less than -1. And by the way, I want you to recall what this is. Okay, what is the square root of x squared plus y squared? Otherwise, known as r. Okay, if you remember, the cylindrical or even polar coordinates, this was known as r. This is the distance from the origin, right, to x, y. So this will have a, what kind of a graph do you expect from this? Maybe the best way to describe this is ripples. Okay, so maybe you can try to figure out what this looks like. Basically, if any point is of the same distance to the origin, then they will give you the same amount, same z value. All right, so if at 0, 0, of course, sine of 0 is 0, and then let's stick to y, the positive y value. It'll go like this, and this is pi, and then 2 pi, right? And go up and down like this. Okay, but the same thing happens in this direction, and in all directions. Okay, so this will be, like I said, this will be a ripple. Okay, and it's hard to graph this, But and you can sketch and graph this on your electronic calculator or your 3D graphing app, which I would strongly encourage you to download. Remember, my favorite one is called Good Grapher or other apps. Try to sketch this and you will see a nice, thing that sort of looks like, what's it called, sombrero, the hat, and you will see the ripples, okay, and it will go in all sorts of directions. And so that would be a sort of an interesting kind of thing here. And because the domain is all of R2, there is no boundary because every point is included. All right, so one very important thing to study in terms of multi-dimensional or multi-variable functions is called the level curves, okay? Level curves for f of x, y. We now focus on a function of two variables, okay? So these are, simply the level curves, okay? Curves with the level value, all right? So curves with the equation f of x, y, of course, that is, some number, but we pick a constant. And so if the constant is 0, we say the level curve for 0, and so on. Okay, now here's a picture, just briefly, of this. Okay, so if you have a function, which let's draw this with a nice color like this. That's not what I wanted to have. All right, so let's say you have nice green hills, okay? So maybe something like this, and then maybe a much higher hill over here, right? And so this is a smooth curve, right? And just imagine the graph of this f of xy looks like, two hills, one small mountain, one tall mountain. And if you slice them at every z level or at particular z levels, okay, maybe here z is equal to 5, 4, 3, and then maybe 2, you have two separate curves here. And then for 1, maybe you have, one like this. All right, all of these curves are called level curves. All right, now, this is, of course, your x, this is your y. All right, let's go back and look at this from the, top view, because normally, these level curves are drawn not on the graph itself in 3D, but in the two-dimensional plane, okay? So just imagine what it looks like. And we are going to do a lot with level curves, so you may want to learn this very, very well. And so this is x, this is y. All right, so this, the whole thing looks like in the first, everything appears to be in the first quadrant, right? So let's say this is where z is equal to 6, z is 5, z is 4, and when z is equal to 3, you get two circles, and then maybe this is z is equal to 2. Okay, and by the way, if z is equal to 2, you see on the other side too, you may have something like this. Okay, that's what z is equal to 2. And then when z is equal to 3, you have this circle, which is, maybe I should color code this here. Okay, so that would be this one, and then there is of course another circle here where z is equal to 3, right? And then when z is equal to 2, how about blue? 4. Okay, so that would be, something like this, and then maybe a brown one here. Z is equal to 5, and maybe it'll be like this, and then you have one more circle in red. Okay. So that's what level curves look like, and typically it's drawn on the two-dimensional, part of the domain. And so learn to do this as well. Now, typically, you don't just have a picture and then, get to sketch this. Many times we have to calculate what the level curves are, but it's really not that difficult because all you have to do is to set that z equal to some constant and figure out what that is, right? All right, here's an example. F of x is equal to the square root of 2y minus x. Okay, what does the, and I'm going to give you a few examples, but what are the level curves? I will say draw some level curves. This is a typical question here, right? It doesn't give you like specific values. Maybe sometimes they will, but sometimes they don't. They want you to just have a feel for what the level curves are going to look like, okay? By the way, if you use these 3D graphing app or something, you can graph this, okay? And then what you can do is to also graph at on the same screen the constant graphs, like z is equal to 5 or 4 or 0 or -5 or something. And then you will see both surfaces on the same screen, and then you will see the intersection curves, and these are the level curves. Okay, so for this one, let's say 2y minus x is equal to a square root of 2y minus x is equal to k. So 2y minus k is equal to x is equal to k squared. So 2y is equal to x plus k squared. And so y is equal to 1/2 x plus 1/2 k squared, right? I think you can graph these rather easily. Okay, in fact, it doesn't take you any time to draw this. See how fast I did this? Okay, well, because all of these, according to my algebra, I mean, this is just a simple algebra calculation. All of these are just lines with slope 2, right? 1/2, okay? So when k is equal to 0, you get y is equal to 1/2 x, which is this. When k is equal to 1, that's a little, tricky. But how about 2? When k is equal to 2, this is 1/2 x plus, 4 divided by 2, it's 2, right? So this will be when k is equal to 2. And in fact, if k is plus or minus 2, they will give you the same answer because this is always going to be a non-negative number. If k is, I think, 4, maybe you get this point here, 4 squared divided by 2. Oh, that's not it, right? So what is that? To be 4 here, this is a square root of 8, right? Plus or minus square root of 8, then you will have this line because square root of 8 square is 8. Divide that by 2 and you get 4. All right, so nothing here, no level curves here because this number will never be a negative number. That's how you can analyze and come up with, identify these level curves. All right, I want you to do this next problem. Draw a few level curves for this function. F of xy is equal to y over x squared. Actually, find the domain, the range, and a few, few level curves. All right, and try this on your own, and then when you come back, we will do the last part of this section on video.